Hey everyone! So I am going to be reviewing the three review documents that I have shared with you all. So document number 1 is reviewing functions, document number 2 is reviewing sequences, and then document number 3 is a topic 1 review, which covers equations and inequalities. So what I'm going to do is I'm going to go through each problem from those 3 worksheets, and I'll move through them, and you can basically watch whichever parts of this video you personally would like to go over. But essentially, I'll be going over all 25 questions that we've done in the last 3 days. So let's go right ahead. We're going to start with question number 1 from review document number 1, reviewing functions. So we're going to review how to tell if a relationship is a function or not. So here it wants us to do which table represents y as a function of x. So I'm looking for which of these tables is a function. Now, when you have tables, what you need to look at is all of the inputs. Now remember that input is the same as the x values. And when you look over at all of these inputs, what you want to do is see if there's any numbers that are repeating. So I'm going to go and look at example A. In example A, I noticed that there's -5 here and a -5 there. Those are repeating input values and they go to a different place. So here it goes -5 goes to -5, and over here -5 goes to +5. Since I have the same input going to 2 different outputs, this is not a function. There's repeating inputs, not a function. Now looking at B, I don't notice any values in the input column that repeat. I have +6, -6, +8, and -8. There are no repeating numbers. So that is my clear indication that this is a function. So I already know that B is my correct choice, but I'm going to also explain C and D. So in C, I'm noticing that there are 2 -3s as well as 2 -1 or +1s. So right off the bat, I have repeating input values that go to a different place. The -3 goes to -4 and +4. The +1 goes to +4 and -4. And since those are repeating, that is not a function. And in my last table, of course, I see that the 2 repeats over and over and over. And that's a big no-no. That tells me that this is also not a function. So the only one that was a function was answer choice B. So that's question number 1. Question number 2, I have the same question. I want to know whether this is a function or not. But instead of a table, now I have a graph. With a graph, we're going to use a different strategy. So here, I'm looking to see if there's anywhere on this graph that the relationship, which is this curve right over here, it goes up and then it goes down. I want to see if there's any place on this graph where the graph kind of like stacks up on top of itself. So that can be a little hard to visualize, but one way that we can sort of figure it out is using the vertical line test. In the vertical line test, you're going to draw a vertical line anywhere on the graph. And you want to ask yourself, how many times does my graph, my relation, cross the red vertical line? And the answer here is that it crosses it once. I'm going to do it one more time. Let's go over here. I have my vertical line, and my graph crosses it only one time. Now notice, I'm not paying any attention to the x and y axes. The x and y axis are not part of my graph. I'm only looking at the curve that goes up and down. So I'm going to do it one last time just to prove. Yep, I've only got one dot. So since there's no places on this graph where I have 2 or more dots stacking up on top of each other, I know that this is a function, so C and D are automatically out. And then with A and B, you have to think back to the actual definition of a function. So thinking back, I know that a function is when each input value goes to one unique output value. So I'm going to write that down. Each input has to go to one unique output. It can't go to 2 different places. So let's read answer choice A. Answer choice A says it's a function because there's only one output for each input. That's exactly what it is. There's only one output, one unique output for each input value. That is my answer. B tries to flip it around on itself. B is kind of trying to say that you would do output to one input, but that's just simply not right. This doesn't work backwards. It goes from input to one output. So that's why A is correct on this one. And number 3, now I have a mapping diagram. So a mapping diagram is very similar to a table, but on a mapping diagram, you're paying very close attention to these arrows. And what you want to look for is if there's any arrows where it branches off and goes to 2 different places. So what I'm actually going to do is I'm going to show a counter example. I'm going to show a different example that branches out, because here there is no branching. But here's what branching looks like. So let's say I had, this is the same. Let's say the 3 went to the 7 and the 9. Notice how this double arrow branches out in 2 different directions. That's what I mean by branching. If it branches like that, this is not a function. If you see any branching, then you know that it's not a function. Well, in our actual example, there is no branching. What we do have is we have an arrow coming from the 3, an arrow coming from the 4, and they kind of meet at the 7. They meet together at the 7. That's different. That's totally okay, because these are 2 different inputs going to the same output. That's fine. However, what you don't want is to have one input going to 2 different outputs, which is why this is a function and the other one would not be. So this diagram is a function since no domain values are repeated. Again, that goes back to the definition of a function. And then finally with number 4, one last way that you might see this type of problem where it's asking if it is or if it's not a function, you want to look at all of the input values and see if there's any repeating numbers. So in letter A, I have a 2, a 4, a 6, and an 8. No repeating values, I am good to go. It's not A. For B, I have 5, 7, 9, 11. No repeating values, I'm good. This is definitely a function. Then I look at letter C and I have 3, 3, 3, 3. I've got a lot of repeating numbers there. All of those 3s are input values and they are repeating. That's how I know that this one is not a function. Now in D, just to double check, I have -8, oopsies, I have -8, -7, -6, and -5. Again, I have no repeating values. Therefore, all 3 of those, A, B, and D, those are all functions. C is the only one that is not a function since I have all of those repeating values. One point I want to make really quickly is that if this was a mapping diagram, if I turned answer choice C into a mapping diagram, it would look like this. I would have a 3, and then 1, 4, 9, and 16. And what would that 3 be doing? That 3 would be branching out to all 4 of the y values. So again, you could look at it both ways. You can, in both cases, you can tell that C is definitely not a function. All right, question number 5. So now that we know what is a function and what is not a function, we can evaluate functions. So evaluating functions is when you're going to just plug a number in, see what you get. So let's read this really quickly. A rock is thrown from a cliff into a ravine. The function h of t equals -16t squared plus 192t plus 2,560 describes the height in feet of the rock t seconds after it is thrown. What is the height of the rock in feet 8 seconds after it is thrown? Okay, so notice this is function notation. When I have function notation, the variable inside of the parentheses is my input value. That's what I'm going to be plugging in. And in this case, t represents, oops, not there. T represents, here it is, t seconds. So I know that this represents my time. So when I go to plug something in, I'm going to be plugging in a number that represents the time. So everywhere you see a t, you're going to plug in whatever value it asks you to plug in. And in this case, it's asking me to plug in an 8 because I want to know what the height is going to be after 8 seconds. So I'm going to plug in 8. Again, everywhere you see a t in the original function equation, you're just going to plug in that 8. And then from there, you just solve, you evaluate the right side of the equation till you get a final answer. So I'm going to follow PEMDAS here. Make sure I'm following those steps clearly. PEMDAS says parentheses first. Well, I have parentheses, but there's nothing going on inside of them, so that one's out. Next, I'm going to do my exponent. So that means I have to do 8 to the power of 2, which is 64. Then I have, well, I'm going to keep writing everything down just like I had it here. So I did my exponents. Now I get to multiply. So negative 16 times 64 gives me negative 1,024. 192 times 8 gives me 1,536. And then I've got my 2560 right there. And then in the final step, I don't need to divide, but I'm going to add everything that's left over. So I'm going to go ahead and add negative 124 plus 1,536. Now I am using my calculator here. I get 512. I was using my calculator, you guys, and just make sure, even if you don't have a calculator in front of you, I'm starting at negative 1,024 and I'm adding 1,536. I'm adding a value bigger than when I started, so I'm definitely going to go up into the positives. That's how I ended up with positive 512. And then I do my last addition here, 512 plus 2560 gives me 3,072. So that's how I got my final answer, which is B. So that's number 5. Let's go ahead and go to number 6 now. Number 6 is similar, but now we got to do 2 different steps. Number 6 gives us a function, so f of a equals 4a minus 5. And then it wants us to know what is f of 3 minus f of 1.5. So this is saying I need to first off find f of 3, then I need to find f of 1.5, then I'm going to subtract those 2 answers. So let's start with f of 3. So f of 3 means that I'm plugging in a 3 everywhere I see my a, because that's my input. So I'm going to have 4 times 3 minus 5. 4 times 3 is 12, and 12 minus 5 is 7. So f of 3 equals 7. Then I'm going to find f of 1.25. Same thing, I'm going to plug in 1.25. I'm going to multiply 4 times 1.25. If you have a calculator, great. If you don't, sometimes I like to think of this like money. If I got $1.25, multiply that by 4, I'm going to end up with $5. So I get 5, and then 5 minus 5, of course, is 0. So f of 1.25 is 0. Now I get to subtract. I'm going to do f of 3, which is 7, and f of 1.25, which is 0, and I need to subtract them. So I get 7 as my final answer, which is B. So not only do you have to evaluate, you have to sometimes do an extra step like we did at the end, which is to subtract. All right, so we've evaluated functions mathematically just now. Well, you can also evaluate functions by looking at a graph. So I'm going to read this problem. Sue hits a ball from a height of 4 feet. The height of the ball above the ground is a function of the horizontal distance the ball travels until it comes to rest on the ground. Consider this complete graph of the function. All right, so this graph shows us the trajectory of the ball, and you can clearly see how the ball goes up and then it comes down. And the question is, what is f of 40 and what does it mean in this context? So there's two things we have to do. First, we have to find f of 40, and then we have to correctly explain what it means. So first off, I know that in function notation, 40 is my input value. And remember, your input value is your x value. So I'm looking at the x-axis, the horizontal distance, and I'm looking for the place where the horizontal distance is 40. Now it's not labeled, but I know that this is going incrementally by 20s, so this is my 40 right here. So I'm going to look at that 40, and I'm going to go up and see what point am I at. And here I'm at 40 comma 30. Because if I look over at my y-axis, so now I'm going to look over to the left, and I see that my point is located on the 30. So my input is 40, my output is 30. So that means that f of 40 equals 30. So f of 40 equals 30. Okay, now I look at my answer choices. I know A is out, and I know C is out, because they were giving me the wrong answers. But now that I know f of 40 equals 30, I need to match it with the correct definition. So take a look. The input is 40, and the input represents the horizontal distance. The output is 30, and the output represents the height of the ball. So I know that my horizontal distance is 40, my height is 30, which means my correct answer choice is D. The ball's height was 30 feet when its horizontal distance was 40 feet. So it all comes down to matching the correct input with the correct output. Number 8, which of the following statements is correct? So we're talking about domain and range. Domain and range, very, very important. It definitely will come up. We have to know how to do this. So the domain is my inputs. So let me write this down. Domain is input values, whereas range is output values. So I have a mix and match of answers here, so I'm going to start by looking at my domain. Since my domain is my input values, it's talking about the x-axis, the horizontal distance. So my question, I always have to think, what is the smallest amount? What is the biggest amount? What's the smallest horizontal distance? Well, it starts at 0. She starts at 0 feet. And then it goes up and it comes back down, and we end up at 200. So I'm going to go ahead and put that 200 down because it's not written, but that is 200. So my domain, my x values, my inputs go from 0 to 200. So I know that my domain is 0 less than x less than 200. And let's see if any of the answer choices match up with that statement, and it looks like I have a possibility. Here in B it says the domain is all integers such that 0 is less than x is less than 200. So now I have to think, is this going to be integers or is this going to be all real numbers? Well, when that question comes up, you have to think, okay, is the ball traveling from 0 to 1, from 1 to 2, from 2 to 3 without making all the distances in between? In other words, is it teleporting from 0 to 1, from 1 to 2, from 1 to 3? Or does the ball travel from 0 to 200 without skipping any places? And the answer is it goes from 0 to 200 without stopping. It's a ball. It's going to roll, or it's going to go from 0 to 200 without skipping anything. So integers, since integers are positive and negative whole numbers, that can't be my answer because my ball is not going through the integers, it's going through all real numbers. So B is out, and A is also out because it's giving us the wrong values. So I know it's not A or B, now I gotta look at my range. Well, my range is the outputs, so this time I'm looking at the heights. I wanna know what was the highest the ball went and what was the lowest the ball went. Well, the highest point was it reached 50 feet. There's my 50 right here. And the lowest point was at the very end when the ball hit the ground again, and that was at 0 feet height. So I know that my range is from 0 to 50. So that is my inequality. And that means D is out. And C, the range is all real numbers. Yep, from 0 to 50. Yep, C is correct. So that's number 8. Moving right along to number 9. Again, we're talking about domain here. And with domain, remember, domain is the input values. So when you have a word problem like this one, you're always going to have to think to yourself, what is my input and what is my output? So let me go ahead and read. Billy buys light bulbs in packs of 8 for $20. The shipping cost is $10 regarding of the number of packs bought. Billy has only $120 to spend. Okay, so there's two things happening here. There's light bulbs and there's the cost. And my question is, which of these is the input and which of these is the output? Well, you have to think about it like, what can Billy control? Can Billy control the number of light bulbs he buys? Or can Billy control the price of the light bulbs he buys? If he's looking through Amazon, he can only control the number of light bulbs that he buys. He can't control the cost because the cost is already set by Amazon or by whatever vendor is selling these light bulbs. So since Billy can only affect the number that he buys, that's how I know that's my input, because that's the only thing he can physically change. He can decide he wants fewer, he can decide he wants more. The cost changes depending on how many light bulbs he decides to buy. So my light bulbs are my input, my cost is my output. So if I'm talking about domain, I know I'm going to want to talk about the number of light bulbs. So here I have a lot of different options. First of all, A and B say all real numbers, whereas C and D say integers. So that's where we have to think. If I'm talking about light bulbs, will it be 1 light bulb, 2 light bulbs, 3 light bulbs, 4 light bulbs, or could I have 1 light bulb, 1.5, 1 3/4, 4.25? Can I have decimals and fractions? The answer is no, because I'm talking about physical light bulbs or packs of light bulbs. So I know that A and B are out because it can't be all real numbers. It has to be only integers, only whole numbers. And then I have to think, okay, is it going to be from 1 to 6 or from 1 to 5? And then that's where it all comes down to the budget. He only has $120 to spend, and there's $10 of shipping. So really, he only has $110 to spend on the actual light bulbs. And since they come in packs of 8 for $20 each, the question is, how many packs of light bulbs can I buy before I hit my limit? Well, if I buy 5 packs, 5 times 20 is 100. If I buy 6 times 20 is 120, but I only have $100 to spend, so I can't buy more than 5 packs, which is why D is correct, because from 1 to 5, that's my limit. I can't go past 5. Okay, that was number 9. And finally, we have number 10. Here's another graph. We're going to interpret what it means. So here we go. Lee uses the graph of the function f of x to express his projected earnings at his new job. Which best describes what f of x equals 40 means in this problem? So in other words, how can I put this into words? If I'm saying f of x equals 40, what am I actually saying? Well, 40 is my output. And based on this graph, output represents the salary he earned. So 40 means $40. The input is the amount of hours he worked. So what I want to know is, how many hours does he have to work in order to make $40? Well, we look at my graph. If I want to make $40, I've got to spend 5 hours working. It all comes down to looking at the graph. So let's look at the answer choices. Does it mean the hours Lee will work per week? No. Is it the hourly rate that he'll be paid? No. Is it the amount of money that he will earn for 5 hours? Ah, bingo. There it is. That's my answer. All right, so that was worksheet number 1. Now I'm going to go ahead and I'm going to open up worksheet number 2. So worksheet number 2 was reviewing sequences. There's 5 questions on this document, so let's go ahead and dive right in. Number 1, the first 5 terms of a sequence are 7, 10, 13, 16, and 19. Which of the following functions define the sequence for all integers n greater than or equal to 1? Okay, so I know I have a sequence. My first step, anytime you have a list of numbers, just like this one, is we're going to organize this into a table. So all of these numbers, they're my output. So when I make my table, I'm going to have an input column and an output column. I'm going to put the numbers from my sequence straight into the output column. So 7, 10, 13, 16, 19. And then my input column, that's just going to be, it's always going to be 1, 2, 3, 4, 5, and so on, because that's my position number. So since 7 is the first number on the list, it gets position number 1. 10 is 2, 13 is number 3, and so on. And now what I want to do is I have all of these answer choices that have different functions. I want to know which of them represents my inputs and outputs. So what I need to do is I'm going to test each of these answer choices to see which one is right. And how I do that is I'm going to pick any 2 points. So I could pick any of them, but I just decided to do 3 and 13. And I'm going to plug them into those functions to see if I get the right answer. So remember, n is my input. N is my input. So for answer choice A, I'm going to plug in 3 as my input. And I should, if it's the right answer, I should get 13 because 13 is the output. But let's find out what happens. So if I plug in a 13, here we go. I'm going to multiply first. 3 times 13. Oh, I'm sorry. I'm not plugging in a 13. I'm plugging in a 3, my bad. I'm plugging in a 3 because that's my input. There we go. And what I want to get is a 13 as my output. So 3 times 3 is 9. 9 plus 7 is not 13, it's 16. So since I didn't get the output that I wanted, I know that A is not my correct answer. So now I'm going to move on and check answer choice B. I'm going to do the same exact thing. I'm going to look at that rule, copy it down, but I'm going to plug in a 3 and see what happens. So I'm replacing all of the n's with a 3. And then I'm going to evaluate and see what I get. So over here, 3 times 3 is 9. 4 plus 9, oh, that's 13. F of 3 equals 13. That's a good thing. That means that I got the right answer. That means that this is probably going to be my answer. However, you always want to check it one more time just to be safe. So I'm going to test another point. I'm going to test 5. So I'm going to do the same exact thing, but I'm going to plug in a 5 this time. And I should get 19 as my answer. So let's check it out. If I plug in a 5, will I get 19? 3 times 5 is 15. 4 plus 15, yep. I got 19. I got another check mark. This guy got 2 check marks. He's good to go. I know B is my answer. Now you could go on and check C and check D just in case, but I will tell you right now that they will not give you the right answer. So therefore, B is correct. Number 2, very similar idea. I'm going to do the same exact thing as I just did. I'm going to start by making my table. Again, the values in the sequence are the output. So the 2, 8, 18, 32, 50, they go in the output column. And the input, we're always going to write 1, 2, 3, 4, 5. Now I'm going to test out these answer choices. Starting with answer choice A. Well, that one's easy. I just have to plug in a number. And let's stick with 3 again. So I'm feeling the number 3 today. I don't know. So I'm going to plug in a 3. I want to get an 18. Let's see if that happens. So I'm starting with answer choice A. 2 times 3. 2 times 3 is 6. It is not, unfortunately, it is not 18. So that one does not give me the answer I wanted. A is automatically out. Testing answer choice B now. Answer choice B is 2n plus 6. So again, I'm going to plug in my 3. 2 times 3 is 6. 6 plus 6 is not 18. It's 12. So again, I can cross out that answer choice because I did not get the value I wanted. So that one's out. Now I'm going to check answer choice C. Answer choice C, 2n squared. So again, I'm plugging in 3. I should get an 18. Let's find out if I do. 2n squared, 2 times 3 squared. PEMDAS tells me that I need to do my exponent first, so I'm going to do that. 3 squared is 9, and 2 times 9 is 18. Yay, okay, I got a check mark. But before I move on, before I say, oh, it's definitely C and move on, I'm going to check one more point just in case. Let's plug in that 5, see what happens. So I'm going to do this one more time, but this time I'm going to plug in a 5 and see if I get 50. Again, I do my exponent first. 5 squared is 25. 2 times 25 is 50. Boom, I am good to go. C is my answer. There you go. So anytime you have a sequence, make a table, plug in values, and see which one is correct. All right, now we got another one, but this time I don't have a list, I have a word problem. So I have to kind of think about what the numbers in my sequence are going to be based on the words on the page. Let's go ahead and read. A farmer has a crop of 2,000 orange trees at the beginning of this year. Each year, the farmer plans to plant 250 new trees. Assuming all of the trees from one year live into the next, which explicit formula below can be used to determine the total number of orange trees, A of n, on this farm at the end of the nth year? Okay, a lot of words, but the most important thing is the pattern that it's telling us about. It tells us that we begin with 2,000, and every year we're going to add 250 new trees. So I'm going to make my input and output table. And I'm going to do it for a couple of values. Now remember, my input is always 1, 2, 3, 4, 5, and so on. Now, my input is representing the number of years that have passed. So in the first year, the farmer has a crop of 2,000 orange trees. So my first value here is 2,000 because that's how much he started with. And then every year after that, he plants 250 new trees. So at the end of the second year, he's going to have 2,250. I'm just adding 250. And I keep going. I'm going to add another 250. So then I have 2,500. Then I have 2,750. And then finally, he has 3,000. So that's my pattern. I'm adding 250 each time. So that's how I got the values for my output. And now I'm going to do the same thing that I just did before. I can either, well, let's do this. Yeah, I'm going to test out, just like we were doing before, I'm going to test out these functions starting with option A. So I am going to test, man, I'm really feeling 3 today for some reason. So I'm going to plug in a 3 and see if I get 2,500. So A of n, A of 3 is 2,250 plus 250 times 3 minus 1. Okay, PEMDAS tells me to subtract whatever's inside of the parentheses first. So I have 2,250 plus 250 times 2. 3 minus 1 is 2. Then I'm going to multiply. So I have 2250 plus 250 times 2 is 500. And finally, I add. So A of 3 is 2,250 plus 500, which gives me 2,750, which is not what I wanted. I wanted to get 2,500 as my output, so this is wrong. A is incorrect. So then I move on to B. This is the same exact process every single time, you guys. It's exactly what you're going to do. You're going to test out each of these individual functions. Answer choice B. I'm going to plug in a 3. 2,000 plus 250 times n minus 1. Again, I'm just copying down this function, but I'm going to replace my n with a 3. PEMDAS tells me to subtract first, so I'm going to do that first. 3 minus 1 is 2. So now I have 2,000 plus 250 times 2, which is 2,000 plus 500, which is 2,500. And boom, that was the answer I wanted. I wanted to get 2,500, so this gets a check mark. And I could test another point out, but I think you guys are getting the hang of this. So I would then go ahead and plug in 5 and see if I get 3,000. And if it does, you can circle answer choice B, and it is your answer. You could do if you do it, you'll see you get the right answer. So that's number 3. All right, number 4. Very, very similar idea, but it's got a slightly different type of equation. So let me just read. Training World magazine suggests that beginner runners build their training by increasing the minutes that they run each day using this sequence: 7, 10, 27, 37, until they have completed a marathon. Which of the following is the recursive definition of this arithmetic sequence? Okay, recursive. With a recursive rule, it's a little bit different. All of these, number 1, number 2, and number 3, those were explicit rules because you just plug it in and you're good to go. The way you can tell if it's a recursive rule is because it's always going to tell you what the first value is. So take a look over here. A of 1 equals 7 is telling me that the first value in that sequence, the first number on the list, is 7, which it is. If I look over here, my first number is 7. So I know A and B give us the correct value for A of 1, but C and D don't because they're telling me it's 0, which is wrong. So automatically I've gotten rid of 2 answer choices. Now let's take a look at what answer choice A is actually saying. We're just going to rewrite answer choice A right over here. So I'm just looking at this part, the actual rule. The rule is saying take whatever number you want, whatever you're looking for, it's going to equal the number before. So A of n minus 1 means the previous number. You're going to take the previous number and add 10 to it. Well, if you look at the actual numbers in the sequence, I have 10, 17, 27, 37. The pattern is I'm adding 10, plus 10, plus 10, plus 10. So answer choice A correctly tells me the rule. The rule is you're going to add 10 to whatever number came before. Answer choice A is correct, whereas answer choice B was saying the opposite. Answer choice B was saying take whatever number came before and subtract 10 from it, which is not going to give us the right answer. So A is the correct answer for number 4. And then in number 5, we have a similar scenario. I have this sequence, 3, 9, 27, 81. The first number in the sequence is 3, which means C and A are out of the question. And the pattern is that I'm multiplying by 3 to get to the next number. So check out answer choice B. Answer choice B, I'm just going to rewrite it, is A of n equals 3 times A of n minus 1. So answer choice B is saying you're going to take the previous number, whatever number came before, previous number, and multiply it by 3. And since that's exactly what we're doing, I know that B is correct. Whereas D isn't telling me to multiply the previous number by 3, it's telling me to divide the previous number by 3 because it has a fraction. Fraction means division. So D was basically telling us the opposite. So those are my 5 problems for sequences. There's 2 strategies. For a recursive rule, we try to read the rule and see what it's telling us and see if it matches, just like these 2 problems. For an explicit rule, we plug in a number and see if it matches with the values in our table. So those are the 2 strategies we're going to use for sequences. So that was the second document. Now I'm going to go ahead and move on to the third document, which is reviewing topic 1, which is equations, inequalities, what else? Literal equations, compound inequalities. There's a lot going on. So very, very important that we understand this topic for sure. All right, so let's dive right into problem number 1. Problem number 1 has an equation, and I'm going to go ahead and solve for x. And there's a few things going on here. I have parentheses. I see I have variables on both sides. So there's going to be, I have to figure out what to do first. And since I have parentheses, if there's nothing else but parentheses, that's always going to be your first step. So step 1 is to get rid of my parentheses, and we do that using the distributive property. So I'm going to multiply. 4 times 1 is 4, and 4 times negative x is negative 4x. I bring down my 2x. Cool. On the right side, negative 3 times x is negative 3x. Negative 3 times positive 1 is negative 3. So that was distribution. Now, I'm rid of my parentheses. Now I look and I try and see what I have here that I need to fix. And what I notice is that I have an x over here and an x over there. I've got 2 like terms on the same side. So step 2 is going to be to combine like terms. So I'm going to add negative 4x plus 2x. I'm going to bring down my 4. And then negative 4 plus 2 is negative 2x. Now I look again and I try and see, what do I need to simplify? What do I need to move? How do I get x by itself? Well, I have variables on both sides. That's bad. I need to bring them all to the same place. I'm always going to try and move whatever's on the right over to the left. And I'm going to do that using inverse operations. Since my 3x is negative, I'm going to add 3x to both sides using my addition property. So since 3x was negative, when I add it, it cancels it out, and that leaves me with 4. Now I need to add negative 2 plus 3 is 1, so 4 plus 1x equals, don't forget the negative, negative 3. Now, 1x is the same. If I have a 1 in front of the x, it's just x. You can just simplify that to just x. And so my last step to get x by itself is to move the 4 to the other side. And I'm going to do that using my subtraction property, because again, you always want to do the opposite. So this is subtraction property. Since my 4 was originally positive, the only way to remove it is by subtracting. Then negative 3 minus 4, be very careful, negative 3 minus 4 only gets me even more negative, so my final answer is negative 7. That was number 1. Number 2, I've got another equation, except now I have these fractions that are going to mess me up if I don't get rid of them. So you always want to get rid of your fractions first. And in this case, I have not just one fraction, but I have a double fraction situation. And whenever you have a double fraction just like this one, you're going to take the denominator from the left and multiply it by the numerator on the right. And then you're going to do the same thing on the other side. Take the denominator from the right side and bring it over to the numerator of the left side. This is called cross multiplication. So I've got that. Let me rewrite it. So now that 3 came up here. So I have 3 times n plus 4. And that negative 2 is now over here. And I've got my new equation. So I got rid of my fractions, but now I've created a new problem for myself, which is that I have parentheses. And as we know, to get rid of parentheses, we distribute. So 3 gets multiplied by everything inside here. Negative 2 gets multiplied by everything inside there. Over on the left, I have 3 times n is 3n. 3 times 4 is 12. Draw my line here. On the right side, I have negative 2 times negative 3n. 2 negatives multiplied makes a positive, so I have positive 6n. And then negative 2 times negative 5, be careful, make sure you don't forget about that negative. That minus sign, we think of it as a negative. So I have negative 2 times negative 5. Again, 2 negatives make a positive, so it's positive 10, plus 10. Now I notice that I have variables on both sides. I have a 3n on one side and a 6n on the other. So I know that I need to move one to the left, and I'm going to do that using my subtraction property. I'm going to move that 6n, since the 6n is on the right, and I want to move it to the left. I do so by subtracting. And now 3n minus 6n is negative 3n. Plus 12 equals 10. I just brought everything else down. Okay, now I want n to be alone. That 12 needs to go away, so I'm going to subtract it out. Minus 12 on both sides. 10 minus 12 is negative 2. So I have negative 3n equals negative 2. And my final step here to get n by itself is to divide by negative 3 on both sides. So that's my division property. So I divide by negative 3. It's kind of hard to see, so let me rewrite that a little better. So my negative 3's cancel out. I have n equals negative 2 over negative 3. But since two negatives, when you divide them, make a positive, I can simplify this. This is positive 2 over 3. Because my numerator and my denominator were both negative, those negatives cancel each other out, and you're left with a positive 2 over 3. So that was number 2. Number 3, now we have a word problem. Here we go. Andrew and Ryan spend a total of $50 at a state fair. There is an entrance fee of X dollars per person, and each ride costs $4.50. If they went on 4 rides, write an equation that models the situation. So I've got some options here. I'm going to quickly glance at my options and notice some patterns. I notice that they're all equal to 50, and that's because they spent a total of 50. So that's why all of these are equal to 50. And then I see some 2s, some X's, I see some 18s, and some 450. Well, I know that the 450 matches with the price of each ride, but where does the 18 come from? Well, you got to read carefully. If each ride is 450, and there were 4 rides, it's telling you right there that you need to multiply 450 times 4. And if you do that on your calculator or on paper, you'll notice that that equals 18. So that's where that 18 is coming from. So I know that answer choice C and D can't be right because they didn't account for the fact that you're going on 4 rides. So you had to do that multiplication. And then finally, I noticed that there's a 2 and then there's a 2x. Well, the 2 is talking about how there's two people. And the X is the entrance fee. Oops, let me highlight. Entrance fee of X dollars. So if the entrance fee is X and there's two people, I have 2X. That's where A comes from. A is my answer. And I'm done. So with this type of question, it's really a lot about matching and looking at your answer choices and trying to see where those numbers came from until you find the one that matches the scenario the best. So let's do another one that's very similar. John and his 3 brothers share a cell phone plan. The cell phone company charges a flat rate of $85 per month, which the 4 brothers share equally. In addition, the cell phone company charges 30 cents per megabyte of data downloaded. Each brother pays for his own downloaded data. John's share of the current cell phone bill is 147.50. Which equation determines how many megabytes of data John downloaded? All right, so again, I'm going to notice some patterns. I notice that every answer choice has 147. Oops, that one's, there must be a typo, but I think that was supposed to say 147.50. But all of them have that. And that's because that's John's total. He's paying 147.50. But what is he exactly paying for? Well, he's paying for there's 2 different charges. There's the flat rate of $85 per month, and if you keep reading, you see that the 4 brothers share that rate equally. So John himself isn't paying $85 per month. All the brothers together are splitting that cost. So that's why you have to divide 85 divided by 4, because there's 4 brothers. You'll notice that that equals $21.25. So if you were wondering, where did that number come from in the equations in answer choice C and D? That's exactly where it comes from. It's because they're sharing. So now I know A and B are out. So I'm looking between D and C, which one matches correctly? Well, the last missing piece is the 30 cents per megabyte of data. Since I know that he's spending 30 cents per megabyte, I don't know how many megabytes he actually downloaded this month, but that's why I have my variable X. So the 30 cents goes with X because that's the value that I don't know. That's the missing piece. So that's why C is correct. D is wrong because they put the X next to the 21.25 instead of putting it next to the 30 cents. So that's why answer choice C is my correct answer. Again, all I did was I matched until I found the correct answer choice. Problem 5. Now I've got a literal equation. Literal equations are the ones that have only variables and numbers. You're not going to get a nice whole number answer. Your answer is going to look like more variables and numbers. So a data set with an even number of data points is ordered from least to greatest. The middle 2 data points are represented by x1 and x2. This formula can be used to find the median of the data set. None of that really matters because all I'm asking for here is which formula is solved for x1. So I know I need to get x1 all alone. Well, right now, x1, there's 2 things happening. I'm adding x2 and then I'm dividing by 2. And since there's 2 things happening, you have to think about, okay, which of those should I get rid of first? If I want to get x1 alone, should I get rid of x2 or should I get rid of that denominator? And the answer is you always want to get rid of the denominator first. You see a denominator, you know you got to get rid of it. And to get rid of it, we multiply by that number. So if I want to get rid of that 2, I got to multiply by 2 on both sides. And what happens is the 2's cancel. On the left, I have 2m. On the right, I have x1 plus x2. Now I'm one step closer to getting x1 by itself. The only thing I need to get rid of is this x2. And since I'm adding x2, I'm going to get rid of it by using the inverse operation, which is to subtract. And I got to do that on both sides. So when I subtract x2, I'm left with x1 all by itself. And then on the left side, I have 2m minus x2 because you can't combine them. So we're keeping them separate with subtraction. And if you look carefully, that matches up with answer choice B, 2m minus x2. Literal equations. All right, moving on. Now, question number 6, we have an inequality. Inequalities work pretty much similarly, pretty much identically to equations. So we're just going to go ahead and we're going to solve. I see parentheses, I'm going to distribute. 3 times 2 is 6. 3 times 1 is 3, -1. So I started with distributing. Now I notice that there's variables on both sides. So I got to move one to the left. And since I have a positive 4x, I'm going to subtract 4x from both sides. 6 minus 4 is 2. Everything else I'm just copying down. I want to get x by itself, so the 3 needs to move over. He's negative right now, so I'm going to add him. 7 plus 3 gives me 10. And now I divide by 2 on both sides, and I get x is less than or equal to 5. There's my answer. Now I'm going to graph it. Graphing inequalities is very simple. You start by making your number line. I know x is less than or equal to 5, so 5 goes in the middle. And I'm going to put 2 points to the right and 2 points to the left. I have a less than or equal to symbol. So what that tells me is I have to have a closed circle on the 5, and my arrow is going to point to the left. The arrow points in the same direction as your symbol. Notice this kind of looks like an arrow. So that arrow is pointing to the left, so my arrow is going to point to the left. The other thing, quickly reviewing, if you have a less than or equal to or a greater than or equal to sign, that's going to be a closed circle. If you have just less than or just greater than, that's going to be an open circle. So that's why I had a closed circle in this problem. Moving on, number 7 is very, very similar, but I have a fraction. So as we know, fractions have to go first. That's the first thing I'm going to eliminate is my fraction. And just like I mentioned earlier, how do you eliminate a fraction? You're going to multiply by the denominator. My denominator is 2. So I definitely want to do that first. I want to multiply by 2 on both sides. So I'm multiplying by 2 on the left. I'm multiplying by 2 on the right. And what happens? On the left, I have parentheses, and everything in those parentheses is basically being protected. It's not going to be touched by my multiplication property. So when I multiply by 2, I'm not multiplying the stuff inside of the parentheses by 2, just the numbers on the outside. So I'm just doing 2 times 2. That's 4. See, I didn't touch my parentheses at all. Same thing on the right. I'm not touching the parentheses. I'm just doing 2 times 1/2. 2 times 1/2 is 1. I got rid of my fractions. Next up is my parentheses. And we know that to get rid of parentheses, we distribute. On the left side, 4 times x is 4x. 4 times -4 is -16. On the right side, 1 times x is x. 1 times -4 is -4. I have x's on both sides. That is bad. Let's move one over. I'm going to move my x to the left by subtracting. 4 minus x is 3x. And I bring down my negative 4. I've got 2 steps left. Step 4, I need to get x by itself, so that 16 has to go away. So I'm going to add 16 to both sides. Negative 4 plus 16 is 12. And my final step is to divide by 3 on both sides to get rid of my 3. And when I divide by 3, I get x is greater than or equal to 4. So this was very similar to the previous problem. I'm going to go ahead and graph it. I've got my 4 in the middle, 2 numbers on either side. Oops, that's a 5. I have a greater than or equal to symbol, which is going to be a closed circle going to the right. That's number 7. Okay, number 8. Oops, I kept this from last time. My bad. Okay, so for number 8, I have a compound inequality now. And a compound inequality is when there's 2 inequalities kind of mushed together. So the first thing you want to do is you want to split them apart. I have my left side, negative 19 is less than 3x minus 4. I highlighted that in green. And then I have my right side, 3x minus 4 is less than 5. I start by solving the left by itself. So just isolating the green side, I'm going to solve for x only on that side. So I'm going to add 4 to both sides, which gives me negative 15 is less than 3x. I divide by 3 on both sides, and I get negative 5 is less than x. Then I do the right side. Same thing, I'm going to add 4 to both sides. 3x is less than 9. Then I divide by 3 on both sides, and I get x is less than 3. Now that I've solved them separately, I can bring them back together. X is in the middle. On the left, I have my negative 5. On the right, I have my positive 3. So negative 5 is less than x is less than 3. That's my final inequality. And now I look at the possibilities to see which of those is graphing x as being in between negative 5 and positive 3. And if you look at answer choice B, that's my negative 5. That's my positive 3. We have open circles on both because we have less than symbols, not less than or equal to, just less than. So I've got open circles and I'm shading everything in between. X is between negative 5 and positive 3. That's number 8. Number 9, I have another compound inequality, but this time this is an OR inequality, so it's not going to be shading everything in between, it's pointing in opposite directions. So I have 2 separate inequalities. I'm going to solve them separately. So let's start with 6x minus 14 is less than negative 14. Let's solve just that one. I'm going to add 14 on both sides. Negative 14 plus 14 is 0. I divide by 6 on both sides and I get x is less than 0 divided by 6 is just 0. Now I'm going to do this inequality. 3x plus 10 is greater than 13. Let me divide this so we don't get confused. Okay. So just the blue, starting out by subtracting 10, and that leaves me with 3x is greater than 13 minus 10 is 3. Now I divide by 3, and I have x is greater than 1. So my final answer is x is less than 0 or x is greater than 1. So now I'm looking for two separate inequalities. One is pointing to the left and one is pointing to the right. And I want one of them to be on the 0 and the other one to be on the 1. And if I notice answer choice C, I have an open circle on the 0 pointing to the left. So that's my x is less than 0. And I have an open circle on the 1 pointing to the right. That's my x is greater than 1. So there you go. That's your answer. Number 9 is C. Finally, number 10, word problem. Similar idea to the previous ones. We're going to play a game of match. So I'm going to read it carefully and match all of that information to the answer choices I'm given. Student council is renting a tent for $350 for an upcoming student fair. Each student attending the fair will pay 50 cents. All other attendees will pay $2.25 each. If 200 students attend the fair, which inequality can be used to determine the number of other attendees, A, needed to cover the cost of the tent? All right, so I'm noticing all of them have 350 because that's the total. Cool, that's easy. Then I see this situation where I have 50 cents and then I have the 200. There's kind of some interesting things going on. So I'm going to look, where does this 50 come from? That 0.50 comes from the price of student tickets. Student tickets cost 50 cents. And then you keep reading, you notice that how many students are going? 200 students are going. So we know how many students are going. What we don't know is how many other attendees will be attending. We don't know that. That's why we have a variable. Those other guys pay $2.25. So if you match it correctly, the 50 cents goes with the 200 and the 225 goes with the A. So right now, answer choice A and answer choice B have the correct matching. The last thing I have to notice is, am I adding those two values or am I subtracting those two values? Well, if you're trying to make those two values add up to $350, you better be adding them, not subtracting them. So that is why B is my final answer. So that is the end of all of the problems that I'm going to go over. So what do you do next? Y'all have this test. It's 15 questions tomorrow on Wednesday, 15 questions on, tomorrow's Tuesday. 15 questions on Tuesday, 15 questions on Wednesday. Everything that I just went over is what's on the test. So equations, inequalities, compound inequalities, functions, sequences, all of those things is what's on the test. So as you watched this video, if there were ones that you were having more trouble on, that's what you want to study. The questions that you were like, Miss, I got this. This is easy. Don't focus so much on those because you know how to do them. Make sure that tonight, other than studying, you get a good night of sleep so that you're ready and fresh in your mind for the test. And that's all I got to say. So good luck. I'm excited to see your scores.